The law of cosine is a very powerful tool that can be applied to any type of triangle. Here I've drawn out a simple triangle which does not include any right angles. To derive the law of cosine, the first thing we have to do is draw a perpendicular line through the triangle, intersecting the bottom C. This line creates a new segment, D, and splits up C into C1 and C2. There's a couple things we can take away from this. I'll make a things we know box. First off, we know that C is equal to C1 plus C2. This is just how we define these terms. Next, we can show that b squared equals c2 squared plus d squared. This is by the Pythagorean theorem when you consider the right triangle formed by b, c2, and d. The next thing we know is the same idea. We know that a squared equals c1 squared plus d squared. This is formed using the other right triangle, a, d, and c1. The last thing we know comes from trigonometry, and as cosine of a, the angle, is equal to c2 over b, which is the adjacent over the hypotenuse of the triangle formed by d, c2, and b. Now that those are out of the way, we can begin the proof of the law of cosine. First, we will start off with the third thing we know, a squared equals c1 squared plus d squared. By rewriting the second thing that we know, we can say that d squared equals b squared minus c2 squared. If we substitute these values in for the d in the first equality, we will end up with a squared equals c1 squared plus b squared minus c2 squared. Now using this equality, we can apply what we know about c1 and c2. Rewriting the first fact here gives us that c1 is equal to c minus c2. Plugging this in for c1 will give us the next equality. A squared equals c minus c2 squared plus b squared minus c2 squared. Now that we have this mess of an equality, we can start simplifying it. If we expand out the c minus c2 squared term, it will cancel out the negative c2 squared term at the end. What we will be left with is a squared equals c squared minus 2c times c2 plus b squared. As our last step, notice that we can replace c2 with b times cosine of a. This is derived by rewriting our last known fact if we multiply both sides by b. Once the substitution is complete, we will be left with the law of cosine, a squared equals b squared plus c squared minus 2bc cosine of a. This can work for any of the three sides of the triangle. All you have to do is make sure that this angle here is opposite of this side length. As you can see on the triangle that I've given you, the angle A is the opposite of the side length A. If we were to rewrite this using b instead, we would have b squared equals a squared plus c squared minus 2ac cosine of angle B. The one for c squared is derived using the same method. Notice that if we were doing a right triangle, like the one I hastily drew over here, the cosine of angle A would evaluate the cosine of 90 degrees. In other words, this entire last term would go to 0 because cosine of 90 degrees is 0. Therefore, we would be left with the familiar Pythagorean theorem instead. And that's it. Using these four simple things we knew, we were able to derive the law of cosine. It's a very powerful tool, and remember that it can work for any kind of triangle. It does not have to be a right triangle. I hope all of that made sense, and thank you very much.